In this lesson, we are going to be working on graphing absolute value functions. So the first thing that we need to talk about is what is absolute value. So a reminder that absolute value is the distance from zero. How far away would we be? So if we're talking about, and remember the absolute value symbol is the straight vertical lines that surround either a number or an expression. So if we're talking about the absolute value of 3, then that's going to be 3 units because 3 is 3 units away from 0. If we were talking about the absolute value of -3, that would also be 3 because it is 3 units away from 0. It's just the other direction. So absolute value is always going to be positive, except if you're talking about 0 itself, because 0 is neither positive nor negative. So an absolute value function is going to be the graph of an absolute value equation, and an absolute value function is going to have the shape of a V, and it's either going to open up or it's going to open down. The vertex is going to be the point of our V, of the absolute value function. And that is the point where the absolute value changes direction. So if it was a function opening down, it would be where it goes up and then down. The part where it changes would be the vertex. Domain. Domain is considered all the x values in our function, and the range is all of our y values, which is also called our output. So therefore our x values are called our input. So when we take a look at an absolute value function, what we're going to see is this equation. Y equals a, the absolute value of x minus h plus k. The great thing is that the vertex is going to be hk. It'll be very easy to find. Notice that in our formula, there's a minus sign. So the h is always going to be the opposite of what you see. So this said minus h, so our h is going to be positive. The k is exactly what we see. So if you see a plus sign here, then you knew that it was a negative number. The role of a, the number in the front called the leading coefficient, has 3 different roles. First, it's going to tell us if our absolute value function is going to go up or down. In other words, how does it open? If the a has a positive value, it's going to open up, and if it has a negative value, it's going to open down. It also determines the width of our absolute value function. How wide is it? The bigger the number, the more narrow and tall it gets. The smaller the number, the fatter or wider it gets. So if the absolute value of a is greater than 1, it's going to become more narrow. The bigger the number, the narrower it gets. And it doesn't matter if that's up or down. If the absolute value of a is less than 1, it's going to be wider. The a value in this case is also the slope of the function. We'll take a look at that in a minute. Now, when you're looking at an absolute value function that is a v, it's going to continue infinitely left and right as it opens, no matter if it goes up or down. So any value you pick for x will work in the function, and so we are going to say that x is an element, that's why there's an e there, of the real numbers. If then we look at the range is how high or how low the function gets. And so our y values are going to be if it's opening up, it's going to be greater than or equal to the k value. That's if we open up. If we open down, it's going to be less than or equal to the k value. So let's take a moment to practice this information. Example number 2. Let's take a look. So the vertex, if you remember, is our hk. Here's our h value, here's our k value, and that minus is part of the formula, so it's going to be the opposite of what we see. So our vertex is going to be at 1, 2. Our leading coefficient is the number in front of the absolute value, and since there isn't a number there, our a value is going to be 1. Our domain, our x values, are always going to be infinite left and right, so x is going to be an element of the real numbers. Our range, since we know that this is going to open up, because the a value is positive, we know that it's going to be greater than or equal to the k value, which in this case is 2. So when we graph this function, the first thing that we want to do is to put our vertex on our graph. If our vertex is at 1, 2, remember we start at the origin and we're going to go 1 to the right and 2 up, and that's our vertex. Now here's the cool part. We're going to use the a value to do the slope. So remember, our slope is rise over run. Well, there isn't a denominator, but we always know that it's over 1 if it's a whole number. So we're going to rise 1 and we're going to run 1. Up 1 and over 1. Up 1 and over 1. Because an absolute value function makes a v, it is symmetrical, meaning the left and the right are exactly the same. So all we have to do is go up 1, but this time we're going to go to the left 1, and we'll draw the other side of our absolute value function. And now we've graphed it. It is a v. Let's go to example number 2, which it says number 3 because we had some other information as well. Our vertex is our hk. And since there's a plus sign here, that means that we know we take the opposite. So it'll be -2 and -3. Our a value is -2, which we know if we write it as a fraction for our slope is -2 over 1. And since it's negative, we know that it's going to open down. Our domain is all of the real numbers because it goes infinitely left and right. And our range, since it's opening down, is going to be less than or equal to -3. So to graph, we start at the origin and we go 2 to the left and 3 down for our vertex. And then we're going to do our rise over run to do our slope. So from our vertex, we're going to go 2 down and 1 to the right. 2 down and 1 to the right. We'll draw that in, and since we know that an absolute value function is symmetrical, we're going to draw the other side going 2 down and 1 to the left. 2 down and 1 to the left. We draw in our absolute value function. Last example for us to try in our notes, example number 4, is we want to find our hk. Since this was plus, that means that it's going to be -3, -1, our hk. Our a value is 1/3, which is positive, so we know that our function is going to open up. The domain, x, is the element of all real numbers. And our range, since we're opening up, we know that y is going to be greater than or equal to -1. When we graph, we start with our vertex. -3, starting at the origin, goes 3 to the left and 1 down. Our a value is 1/3, which means we're going to go up 1 and over 3, up 1 and over 3, and we're going to draw in our absolute value function. It is symmetrical, so we're going to draw on the other side. Up 1 and to the left 3, up 1 to the left 3, And notice that this one is wider because our absolute value function has a leading coefficient of 1/3, and 1/3 is going to make this a wider function. Ladies and gentlemen, it is now your turn to complete problems 1, 2, and 3 on the student examples, and we will take a look at those when we return.